Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about one complex DC circuit. In this circuit, we will compare brightness of identical lamps before and after closing the switch. This is kind of typical question and very important question to understand complex DC circuits. First of all, let's try to understand what is given to us. For this question, if we read this question carefully, it is given to us that there are three identical lamps L1, L2 and L3. They are connected to a battery and battery has no internal resistance. What we need to find out, simply we need to compare the brightness of lamps L1 and L2 when the switch S is closed. Means simply when we close this switch, we need to compare the brightness of L1 and L2, or simply we can say we simply need to compare the power. As we understand, power means the P here is for power and the power is linked with brightness. Higher the power, brighter the bulb, and vice versa is also true. If the power is greater, brightness will be greater, and if the power is lower, brightness also will be lower. Let's try to answer this question now. So the first thing what I will do is I will redraw this circuit so you can get clear picture. Let me redraw first of all. As you can see here, I have already redrawn these two circuits. Means these two circuits, they are identical. If you look at circuit 1 and the second circuit and third circuit, they are identical circuit, but just shape is different, but circuit is the same. As you can see, the resistance is not given to us, so we can simply assume that resistance of this lamp, let's say, is R. So the resistance of this lamp and this lamp is also R. As you can see in question, it is given to you the lamp, first lamp, this is L1. We can also say that this is L1 and this is L2 and this lamp is L3. And also we can write down here L1, this is L2 and this is L3. Now let's try to calculate total resistance of the circuit. Now we need to calculate total resistance. We can simply say R total. This is equal to resistance of L1 plus resistance of the total resistance of these two resistors. As you can see, these two resistors, they are connected in parallel. Means these are two lamps, so I simply said these are two resistors, so it's the same thing. A total resistance of these two lamps, this is equal to R by 2, so simply we can write down here. So the total resistance is equal to 3 by 2 R. Now let's try to calculate total current in the circuit. So I total simply is equal to EMF of this power supply. Let's say EMF of this power supply is equal to E. We can write down E divided by R total. R total we have already calculated, so we just need to divide EMF by R total. We can say this is 3R by 2, or we can simplify and we can write down this is 2E over 3R. So this is I total. Now let's say current coming from this power supply is I1, and at this point, means at this junction, current will split into two parts. Let's say I2 is passing through L2 and I3 is passing through L3. So we can say in this case I1 will be equal to I2 plus I3. But you also need to understand the total current is equal to I total, so I total is equal to I1. Now as these two lamps, they have the same resistance, we can also say that I2 is equal to I3. So then we can simply say that I1 is equal to 2 times of I2. So these are the main points we need to understand, and then we can calculate power of lamp 1 and we can also calculate power of lamp 2. Let's try to calculate P1 first. P1 means the power of lamp 1. In order to calculate P1 means the power of lamp 1, so we can simply say P1 is equal to I1 squared times R, and I1 is equal to I total, so we can simply say that this is equal to 2E divided by 3R multiplied by R. If we simplify this one, we will get this is 4E squared divided by 9R. So this is value of P1. Now let's try to calculate what is value of P2 means the power 2 we can calculate as I2, this is equal to I1 by 2. So simply we can say I2 is equal to 2E divided by 6R. So this is value of I2. Now we can calculate value of P2. P2 will be simply equal to I2 squared times R. As we understand, I2 is equal to 2E divided by 6R and square of this multiplied by R. If we simplify this one, we will get this is equal to 4E squared divided by 36 times R. So this is value of P2. So we have calculated P1 and we have also calculated P2. Now simply we need to compare these two values. First of all, let's try to calculate the ratio between P1 and P2. Means P1 divided by P2. So if we divide P1 by P2, we can simply say that P1 is equal to 4E squared divided by 9R and it is multiplied by 36R divided by 4E square. So this is 4E square. Simply we can cancel these two, and R we can cancel with R, and if we divide 36 by 9 we will get 4. So it simply means the ratio is equal to 4. Or we can say that P1 is equal to 4 times of P2. We can also simply say P1 is greater than P2. So this one is simply telling us that lamp 1 is brighter than lamp 2. So lamp 1 is brighter than lamp 2. So it means this is the right answer. B is our answer. So how many times L1 is brighter? L1 is 4 times brighter than L2. Now let me explain to you how to answer this type of questions in your final exam. Let's say this question is on your final exam and you need to answer this question. But in exam you have only around 1.5 minutes for each question. Means 1.5 minutes for one question. So time is very limited, so we need to be very quick to answer this type of questions. So if this question was on exam, so the simple way to answer this question is as current coming from battery, let's say this is I1, and at this point this current will split into two parts, I2 and I3. So we can also write down in this case I1 will be equal to I2 plus I3, and as these lamps are identical, means they have the same resistance, R2 is equal to R3, so we can say that I1 is equal to 2 times of I2. So simply you can say I1 is greater than I2. So R is the same, R1 is equal to R2. So then simply you can say P is directly proportional to I square, as we simply understand P is equal to I square times R. So we will say P1 is greater than P2. So simply you can find your final answer. But if they ask you how many times lamp 1 is brighter than lamp 2, then you have to use formula. You will simply say P1 is equal to I1 squared times R and P2 is equal to I1 by 2 squared times R. Now if we solve this one P2, what we will get? We will get this is I1 square times R divided by 4. So this one is P2. P2 is equal to P1 by 4. So it means P1 is equal to 4 times of P2. So P1 is 4 times brighter than P2. So this is how you can answer in your exam. With enough practice, even you don't need to do any calculations and you can answer this type of questions. You just need practice. If your concepts are clear, these questions are just piece of cake. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about one great question from Cambridge AS Physics. This question is great because it will really test your understanding of DC circuits and components of circuits. This question is tricky and also confusing for many students at the beginning. So watch this video carefully to improve your conceptual understanding of DC circuits and components of DC circuits. For this question, it is given to us that the power supply has negligible internal resistance. It simply means that R is equal to 0. We are talking about ideal case. For ideal cases, we can also assume that the resistance of fuse is almost equal to 0, means is negligible, and the resistance of switch is also negligible. And also we are using connecting wires, and those wires are also ideal wires. These are ideal, mean their resistance is also equal to 0. Now the next thing, it is given to us a voltmeter is connected between negative terminal of battery and C1. Our voltmeter is connected here between these 2 points. Voltmeter is connected here. As you can see here, the wire is ideal wire. This wire is ideal, so it has no resistance. So it simply means that if I connect voltmeter between C1 and C2, if we connect voltmeter here between C1 and C2, these two voltmeter, they will give us the same reading. So in this case, V1 will be equal to V2 because this wire is ideal wire and there is no voltage loss. It is given to us with the circuit working correctly. The voltmeter reading is noted with the switch closed. Means our voltmeter is connected here between C1 and C2. We recorded the reading and that reading will be equal to 110 volts. So this is equal to EMF of power supply. Now, question is asking us which fault would result in the same 2 voltmeter readings. So it simply means that when there is a fault in the circuit, again we will see the reading, the potential difference across C1 and C2, that is equal to 110 volts. So we have 4 different types of faults and 4 options we have. We need to choose the right option. Let's look at option D. First of all, when there is a short circuit. Short circuit simply means that you can see here, you can imagine it's just a wire. If it is just a wire, it means there is no potential difference if you connect our voltmeter here. So in this case, for option D, this is option D, voltmeter reading will be equal to 0. So this is not our answer. If we go to part C, melted fuse, it means circuit is broken, or we can simply say this is open circuit. In this case, our circuit is broken. If we look at this point and this point, we can see the potential at these 2 points will be the same because there is no power supply tie between them. So we can simply say, in this case, if we attach voltmeter between C1 and C2, again reading will be equal to 0. So this is also not our option. It means it's not answer. If we go to B now, you can see for part B it is given broken switch. The switch is broken. So again, if we take this point and this point, the potential here will be the same, and so we can simply say, in this case, if we attach voltmeter between C1 and C2, again reading will be equal to 0. So this is also not our answer. For A, it is given a break in the wire of the heater. So here means the wire of the heater. So you can see here, in this case, the potential at C1, that will be equal to 110 volts because this is connected with positive terminal, and C2 is connected with negative terminal. So we can say potential here will be 0 volts. We can assume. So in this case, you need to understand the potential difference. If we attach a voltmeter here, or we can say the reading on voltmeter, that will be equal to EMF of the battery. That will be equal to 110 volts. So this is our answer. So this one is answer. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about one complex DC circuit problem from Cambridge AS Physics. For this question, it is given to us that ammeter reading is 0. It simply means that there is no current passing through this ammeter. So this is what is given to us. And question is simply asking us, we need to find out the resistance of resistor R. So our resistor R is connected at this point. Now, as it is given to us that there is no current passing through this ammeter, it also simply means that potential at these 2 points is the same. Simply, if we connect our voltmeter between these 2 points, the reading on this voltmeter, that will be equal to 0. Now let's label some points before we answer this question. Let's say this point is P and this point is Q, and let's say this point is R and this point is S, and this point is T and this point is, let's say this is U. First of all, let's try to find out direction of current. I will simply draw one possible direction of current, and then I will ask you one simple question about that. Let's say current flow like this. Now, my question for you is that, is it possible that current flow like this? Take some time and try to answer this question. Is it possible or not? Especially you need to look at current in this wire. Okay, let me explain to you now. If you look at this wire, you can simply see that current is flowing in 2 directions. Means current is flowing to the left and current is also flowing to the right at the same time in the same wire. It means current has 2 different directions. So is it possible? I hope simply you will say that not possible. So it simply means there is no current passing through this wire. As there is no current passing through this wire and also there is no current passing through this ammeter, so it simply means that these are 2 different circuits, or I can simply say that in this circuit current will flow like this. Current will flow like this, as you can see. So this is one circuit. We can treat this one as one separate circuit, and in this circuit current will flow like this. current will flow like this. So this is another circuit. So we have two different circuits now. So here is one circuit and here is another circuit. Now, what is common between these two circuits? If we look at point P and if we look at point Q, this is our point Q and this is our point P. Potential at these 2 points is the same. We can simply write down Vp, this is equal to Vq, and these 2 points, they are at zero potential. We can simply say is equal to 0 volt. Now, potential at point R is also equal to potential at point S. We can simply say VR is equal to Vs. Now, the next thing, the question is that how we can find out potential at point R. In order to find potential at point R, we can also simply write down that the potential at point R is equal to potential difference across this 100 ohm resistor. Let me clean first of all. It simply means that potential at point R, this is equal to potential difference across 100 ohm resistor. It simply means that if we connect our voltmeter between these 2 points, meaning between P and R, the reading on this voltmeter will be equal to the potential at point R. Why this will be equal to potential at R? Because point P, this is at zero potential. So we can simply say potential at point R, that will be equal to potential difference across 100 ohm resistor. So we can simply say that that is equal to potential difference across 100 ohm resistor. So R is equal to 100 ohms. Now the question is that how we can find out the potential difference across 100 ohm resistor. So we can simply say this is our 100 ohm resistor. Now we need to find the potential difference across this one. As you can see in this circuit, we have only 2 resistors, and these 2 resistors, they are connected in series. So we can simply find out the potential difference across 100 ohm resistor by just dividing resistance of 100 ohm resistor by the total resistance of the circuit, mean this circuit. So the total resistance of this circuit in this case, that is equal to 50 plus 100. 50 plus 100, and we need to multiply by EMF of power supply, that is 12. So in this case, the potential difference across 100 ohm resistor, that simply will be equal to 8 volts, and this is the same as potential at point R. As the potential at this point R we have already found, means the potential at point R, that is equal to 8 volts. It also tells us that the potential at point S, that is also equal to 8 volts. As we know, the potential at point S now and the potential at point Q, that is equal to 0 volt. It simply means that if we connect our voltmeter across this 200 ohm resistor, the reading on this one, that will be equal to 8 volts. Now as you can see, the EMF of power supply, this is equal to 24 volts, and the potential difference across 200 ohm resistor, that is equal to 8 volts. So simply we can also say that if we connect our voltmeter between point P and point S, reading on this voltmeter, that will be equal to 16 volts. Now as you can see here, resistor R and 200 ohm resistor, they are connected in series. It means same current is passing through R and same current is passing through 200 ohm resistor, but the potential difference across R is double than potential difference across 200 ohm resistor. From here simply we can conclude that R is 2 times of 200. So it means the resistance of R is equal to 400 ohms. Or we can also simply find out in a different way. As you can see, current passing through 200 ohm, let's say this is I1, we can say this is I1, and let's say current passing through this one, that is I2. But in this case, I1 is equal to I2. So simply we can say the potential difference across 200 ohm resistor means the V1 divided by its resistance, means that has to be equal to the potential difference across resistor R divided by the resistance of R. Let's say that resistance is R2. R simply we can write down R is equal to 200. So V is 16. So we have to find value of R. So this is just simply you will find out that R is equal to 400 ohms, and that is over R. So our answer for this question is 400. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss a challenging question on electric field from Cambridge AS Physics Paper 2. Part A is simply asking us to define electric field, and we understand that E is equal to F over Q. But for this question, you cannot simply write down E is equal to F over Q because question is asking you to define. When question asks you to define electric field, you can define like this. You can simply say E is equal to force per unit positive charge. Now the question is that why positive charge we need to mention, not negative charge? Because electric field lines tell us direction of force on positive charge. It simply means that if we have two plates, let's say one plate is positive, one plate is positively charged and the other plate is negatively charged. If we place unit positive charge between these two plates, this charge will experience force downwards, and that is direction of electric field. So simply we can say that E is equal to force per unit positive charge. For part B, it is given to us that two very small matter spheres X and Y. They are connected by an insulating rod of length 72 millimeters. The length of the rod is given, that is 72 millimeters. And the rod is placed inside uniform electric field, and value of E for electric field is given, and it is also given to us that electric field direction is vertically upwards. For part B1, we simply need to calculate the separation between the plates, and the potential difference between plates is given, that is equal to 4.0 kilovolts. So simply we can write down delta V is given, that is 4.0 kilovolts. And electric field is also given, means the value of E is given, the magnitude of E is also given. We can simply write down this is 5.0 times 10 to 4 volts per meter. And for this question we need to calculate separation. It means we need to find the value of D. So D we can simply write down, this is equal to delta V over E, because E is equal to delta V over D. Now simply we need to plug in values, and if we plug in values of delta V and E, we can find out value of separation between plates. If we just do these calculations, our final answer will be 8.0 times 10 to negative 2 meters. And this is value of separation between plates. For the second part, we need to describe the arrangement of the two plates, and in our answer we need to include the sign of the charge on each plate. And it is also optional if we want to draw on figure 4.1 we can also draw. Now let's try to understand how the plates are arranged, because in the figure side view is given to us and electric field is given, the magnitude of E is given, and this electric field is uniform. So it is also given to us that the electric field is pointing up, direction of electric field is up. So it simply means this plate has to be positive and the top plate has to be negative. So in this case, electric field is simply pointing up, means is vertically upward. So this is how we can draw electric field. Now next thing what we need to understand is that the plates, they are in the horizontal plane. As you can see, this plate, this is in horizontal plane, and this plate is also in horizontal plane. And let's try to understand how the rod is placed. And the rod is placed like this. So this is how the rod is placed between the plates. So this is all what you need to understand, and then you can write down your answer. So the plates are in horizontal planes and the rod is in vertical plane. Now let's try to write down our answer. So this is how you can write down your answer. Simply you have to mention first part, you have to mention the arrangement of the plates. So in this case we have mentioned that plates are arranged in horizontal plane above and below the rod. The second part was asking us the sign of the charge on the plate. In this case, the top plate is negative, as I have mentioned here. This plate is negative, and the bottom plate, this is positive. So this is how you can answer this question. For this question, we simply need to determine the magnitude and direction of the force on sphere Y. And sphere Y is connected at the end of this rod, and the charge on this sphere is negative. Let's try to understand direction of force on charges when they're placed in uniform electric field. Let's say this bottom plate, this is positively charged, and this top plate, this is negatively charged. So then the direction of electric field will be simply pointing upwards, mean vertically upwards. So in this case, if we place our positive charge in this plate, direction of force on this charge will be in direction of electric field, mean this force will be pointing upwards. Mean this positive charge, this will experience force upwards but along direction of electric field. Very important point, along direction of electric field. Simply we can say along direction of field lines. Now let's say if we place a negative charge inside this uniform electric field, this negative charge, this will experience force vertically downwards, but this force also along direction of field lines. So this is the main concept you need to understand. If you place any charge in electric field, that charge will experience force along direction of field lines. If the charge is positive, it will experience force from positive plate to negative plate, means high potential to low potential. But if it is negative charge, it will experience electric force from negative plate to positive plate. In this case we have a negative charge, so it will experience force in opposite direction of electric field. As you can see here, we have placed this negative charge in this uniform electric field. So the force on this sphere will be pointing vertically downwards. So this is how we can determine direction of force on the sphere. So we can simply say vertically downwards. Let's try to find the magnitude of force now, and force, electric force is simply equal to F is equal to EQ. In this case, value of E is given, that is 5.0 times 10 to 4. And the charge on this sphere is 3 times of the charge on single electron. So this is 3 times E means 3 times of the charge on single electron. E is the elementary charge. So it means 3 times 1.6 times 10 to negative 19. If we just simply multiply this one, we can find value of force, mean magnitude of force on this sphere Y, and that value is 2.4 times 10 to negative 14 newtons. For this part, it is given to us that the electric forces acting on the two spheres, they form a couple, and the magnitude of the torque of the couple is given, that is equal to 6.2 times 10 to negative 16 newtons meter. We need to calculate angle theta of the rod to the horizontal, means we need to find the value of this angle. But in this question, hint is given to us torque of a couple. So we need to use the concept of torque of a couple to answer this question, means to find the value of angle. Let's try to understand this arrangement first, how the forces are acting on this rod. For this question, it is given to us that electric field is vertically upwards, so the force on this sphere will be vertically downwards because this is negative, and the force on this sphere will be vertically upwards because this sphere is positively charged. So these are two forces, and we can also draw the line of action of these forces. So this is the line of action of force on positive charge, and this is line of action of force on negative charge when they are placed in this uniform electric field. Let's try to understand a little bit about torque of a couple. Let's say we have this one rod. You can simply understand this is one rod. So this is one rod, uniform rod, you can imagine, and there are two forces acting on this rod. One force is acting on this end, and this force is acting vertically upwards, and the other force is acting on this end, and this force is acting vertically downwards. And these two forces, they have the same magnitude, and they are separated from each other, and they are not acting along the same line. They're not acting along the same line. If these two forces have the same magnitude, they have opposite directions, and they're separated by a distance, and the magnitude is the same, these forces will form a couple and they will produce torque. In this case, you can simply imagine that this rod will rotate about its center, let's say about this point. If we need to find the magnitude of the torque, simply what we need to do is we can write down here torque of a couple. First, let me explain a little in detail. So the torque of a couple means the magnitude of the torque you can simply find out by taking magnitude of one force and multiplying with perpendicular distance between lines of action of forces. So what exactly it means by line of action of force? This line is called line of action. So line of action means the force is acting along this line. Line of action of force. Now let's imagine this distance is d by 2 from the pivot, and this distance is also d by 2. So simply you can say the distance between line of action of these forces, this is equal to d. So the tau in this case will be simply equal to F times t. So we can calculate F times t. So that will be torque of a couple. Now let's try to understand this arrangement now. Now we have two forces, and this is line of action of force on negative sphere, and this is line of action of force on positive sphere, and the perpendicular distance between lines of action of these forces is equal to d. But in this case the value of d is not given to us, so how we can calculate? If I draw this line here, means the horizontal line, you will also simply say this angle is theta. Now you see the length is given, the length of the rod is given, that is 72 72 millimeters. So this D simply will be equal to 72 cosine of theta. Now we can write down here tau has to be equal to force times D, but D in this case is equal to 72 cosine of theta. So we can write down this is FD, this is FD, or you can say this is force times 72 cosine of theta. Value of force we have already calculated, and that value is equal to 2.4 times 10 to negative 14, and the 72, as this is given in millimeters, so we have to multiply by 10 to negative 3, and this is cosine of theta. Tau is also given, the value of tau is given, that is 6.2 times 10 to negative 16. Now if we simply solve for angle, the value of the angle will be 69, and this is our final answer. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about one complex DC circuit problem from Cambridge AS Physics past papers. This question is a little tricky one, but a great question to improve your conceptual understanding. In order to get maximum benefit from this video, you can do this question first of all by yourself and then come back and watch the video. For this question, a network of resistors is given to us, and each resistor has a resistance equal to 1 ohm. So we can also say these resistors are identical resistors. What we need to find the potential difference V across the input terminals, Or we can also say that if we attach a voltmeter here, for example, across these terminals, so we need to find the reading on this voltmeter. Let's try to understand some basic concepts first and then answer this question. Let's say the EMF of this battery is equal to 9 volts, and this is resistor 1 and this is resistor 2. So if I ask you what is the potential at this point, you will simply say is equal to 9 volts, and potential at this point will be equal to 0 volt. And if I ask you what is potential at this point, you will also say simply it is equal to 9 volts, because this wire is an ideal wire. There is no loss of energy, there is no loss of potential, and potential at this point will be equal to 0 volt, because again this is the same wire and it is connected with negative terminal of the battery, so this is 0 volt. And potential at this point again will be equal to 9 volts, and at this point will be equal to 0 volt. Now if we attach a voltmeter across this one, the reading on this voltmeter is equal to 9 volts, means the potential difference across this resistor is equal to 9 volts. And the same is true for the second resistor. The reading on this voltmeter also will be equal to 9 volts. The second concept we need to understand, V is equal to IR, means Ohm's law is simply telling us if we have this resistor, let's say its resistance is equal to R and current passing through this resistor is equal to I, the potential difference across this resistor will be equal to V. So these are two main concepts we need to understand, and then we can answer this question. Now as you can see here, current passing through this wire is equal to 1 amps. So we can also say current passing through this wire is also equal to 1 amps. And current passing through this resistor is also equal to 1 amps. Now if we attach a voltmeter at this point, and let's say we attach voltmeter at this point, and so what will be the reading on this voltmeter? So simply you can find out the potential difference across this one is equal to 1 volt, and potential difference across this one is equal to 1 volt. So the reading on this one will be equal to 2 volt. Now again, let me ask you another question. If we attach voltmeter at this point and at this point, what will be the reading on voltmeter? Now let's say here. So what will be the reading on this voltmeter? You will say it will be equal to 2 volts. The reason is that if I just move from here to here, between these 2 points, we just have an ideal wire. There's no loss of energy. There is no voltage drop. So this also will be equal to 2 volts. Now, as we now understand the potential difference across this resistor is equal to 2 volts and its resistance is equal to 1. So how much current is passing through this resistor? We will simply say this is equal to 2 amps. And this is according to Ohm's law. If this is 2, we need to find the value of I, and resistance is equal to 1. So simply I will be equal to 2 amps. So the current passing through this resistor is equal to 2 amps. Now the next step what we need to understand is, let's label these points now. Let's say this is point A, this is point B, this is point C, this point is D, this is E, let's say this point is F. Now, as you can see here, the voltage across CD, we have found this is equal to 2 volts. Now, as you can see, current passing through this resistor is 1 amps and 1 amp, and current passing through this one is equal to 2 amps. How much current is entering into this junction? So according to KCL, we can simply say I entering has to be equal to I leaving. So it means current leaving is equal to 2 plus 1. So current entering is equal to 2 plus 1 is equal to 3 amps. So current at this point we can also say is equal to 3 amps. Now if we attach a voltmeter at point B and at point D, what will be the reading on that voltmeter? Let's say we attach voltmeter here. We attach voltmeter between these 2 points, between points B and between points D. So BD here, BD. So that will be equal to the voltage across BC plus the voltage across CD, So the voltage across BC we can find from here. This will be equal to 3 volts, and voltage across CD already we have 2. So the voltage across BD is equal to 5 volt. Now if I move this one from this point to this point now, let's say I move to this point now. So now what is the reading on this voltmeter now? So again you will see the reading on this voltmeter will be equal to 5 volts, because between D and E there is an ideal wire, there is no voltage drop, there is no energy loss. So we can say the BD is also equal to the potential difference across BE. So we have found the potential difference across BE, that is equal to 5 volts, means potential difference across this resistor is equal to 5 volts. So how much current is passing through this one? So we can simply find that is equal to 5 amps. Now, look at this junction now. So how much current is leaving this junction? That is equal to 5 plus 3 amps. So means 8 amps. So how much current is entering? That has to be equal to 8 amps. 8 amps. So the next potential difference we need to find across point A and across point E. Let's say we try to attach voltmeter between A and E. So what will be the reading on this voltmeter? So that reading will be equal to the potential difference across this resistor plus the potential difference across this one. So the potential difference across this resistor will be equal to 8 volts and across this one is equal to 5. So we can say V8 E will be equal to potential difference across AB plus the potential difference across BE. Across AB is equal to 8 and plus across BE that is equal to 5. So it means the potential difference across AE is equal to this, is equal to 13 volts. So is 13 volts. Now my question for you is that, now if I connect this voltmeter across AF, so what is the reading on voltmeter? Means what is the potential difference across AF? Again you will say this potential difference is equal to AE because there is an ideal wire, there is no potential drop or there is no energy loss. So that is equal to 13 volts AF. And as you can see here, if I attach voltmeter here, for example, here now, so this is equal to 13 volts. How about across these input terminals? That is also equal to 13 volts. So we can say 13 volts. So our answer for this question is D. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about one challenging question from Cambridge AS Physics. This question will challenge your understanding of electric current. For this question, it is given to us that there are two metal plates and they are separated by a distance of 30 centimeters in a vacuum. And the speed of electron between plates is given, that is equal to 1.5 times 10 to 6 meters per second. It is also given to us that at any instant there is just one electron traveling between the plates. What we need to find out, simply we need to find electric current between the plates. In order to get maximum out of this video, you can pause the video, try question first by yourself and then come back and compare your answer with my solution. For this question, we simply need to find I, and we simply understand I is equal to Q over T, or we can simply say current is equal to rate of flow of charge. So for this question, it is given to us there are two plates and the separation between plates is also given, and this separation is equal to 30 centimeters, or we can say this is equal to 0.3 meters. And electron is moving, is traveling between these two plates, and the speed of electron that is also given to us, that is 1.5 times 10 to 6 meters per second. Now as there is just single electron is traveling between the plates, so simply we can say that in this case Q is equal to 1.6 times 10 to minus 19 coulombs, and this is charge on single electron. Now, the next thing is that we need to find out time. So how we can find out time, as the distance is given to us and the speed of electron is also given, so we can simply calculate time. So the time will be equal to distance divided by speed. So distance in this case is 0.30 meters and the speed of electron is 1.5 times 10 to 6 meters per second. So we have value of time, we have value of Q. If we just simply divide, we can find current. So I will just write down here. So I will be equal to Q over T. Otherwise, simply we can say this will be Q V divided by D. So this is, if we just plug in numbers, we can find our answer. So here is complete solution I have written for you. So you can see here, first of all, I is equal to Q over T, and we have V is equal to distance over time, means this is our very basic understanding about speed. And so we can say the V is equal to D over T, and we can say T is equal to D over V. So here we have written our formula, I is equal to Q over T. So we can also write down I is equal to Q V over D. So this is value of Q, charge on single electron. So this one is charge on single electron. This is charge on electron. So here is charge on electron. This is speed of electron. So this is V, and this is the distance between plates. If we simply solve, we will get this is 8.0 times 10 to negative 13 amps. So this is our final answer. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. This is our second video on complex DC circuit problems from Cambridge AS Physics. In this video, we will explore more about complex DC circuits. This is our second complex DC circuit problem, and in this circuit we have 4 resistors and they are not identical resistors, mean their resistance is different. And a voltmeter is also connected in this circuit, and reading on this voltmeter is equal to 0, and this is very important point for us to answer this question. So what we need to find out, we simply need to find the equation for this setup. In order to answer this question, let's say this point is point A, and this point is B. This point is B. As it is given to us that reading on this voltmeter is 0, it simply means that the potential at point A is equal to potential at point B. Means the potential difference between point A and B is equal to 0. Simply, this is what we can conclude from here. Now, let's say current coming from this battery is I, and at this junction, current I will split into 2 parts. Let's say I1 is passing through resistor P and I2 is passing through resistor R. As the potential at this point, potential at this point is the same, and potential at A is equal to potential at B, we can also conclude that if we attach one voltmeter, let's say voltmeter 1 across resistor P, and we attach another voltmeter across resistor R, so the reading on voltmeter V1 has to be equal to V2. Another way of writing this one is we can say I1P has to be equal to I to R, and this is based on Ohm's law. Now we can rearrange this. We can say I1 over I2 has to be equal to R over P. R over P. Now let's move on to next resistor. Now next resistor is Q. The potential at this point are the same, and potential at this point and at this point is also same. So we can also attach another voltmeter across this resistor Q and another voltmeter across resistor S. From here we can also simply conclude that V3 has to be equal to V4. As you can see, there is no potential difference between A and B. It means the same current I1 is passing through Q and same current I2 is also passing through S. I2 means the same current through resistor R. So we can say I1 times Q is equal to I2 times S. From here we can rearrange, we can get I1 by I2. This will be equal to S over Q. So we can also say this equation, let's say this is equal to 1 and this one, let's say, is equal to 2. So as I1 over I2 is equal to R over P and I1 I2 is equal to S over Q, we can say that R over P is equal to S over Q. S over Q. Now from here, if we simplify this one, we can get PS will be equal to Q times R. So this is our final answer. This is what question was asking us. So our answer for this question is D. So this is how we can find out. This is a little long actually method, but let me explain to you shortcut method. So this is actually kind of Wheatstone bridge circuit. This is Wheatstone bridge circuit. So if the reading on voltmeter is equal to 0, we can say Wheatstone bridge is balanced. So if this is true, Wheatstone bridge is balanced, then the ratio between this resistor and this resistor is always equal to the ratio between next two resistors, Q and S. Q over S. So then simply we can find our answer that PS will be equal to QR. So next time, simply if you can identify Wheatstone bridge circuit and then if you can check is it balanced or not. If it is balanced, then simply you can use this ratio method and you can find your answer. This is a shortcut method.